So, uh, so in our till last session, we have already covered some of the instructions as well as regarding the architecture as well as regarding the pin diagram of the 8086 processor. Fine. Am I audible now?
Madam, can you please loudly, please loud?
Still loudly? Okay.
Ma'am, if your voice is not well, then
No, it is well. Uh,
we just
I'll try my level best to uh, speak still loudly. Okay. You do one thing. Can you shift forwards bit? Hello. Is my screen visible to you all? Okay. So, uh, what I have observed in your sessional from my portion, okay, most of the mistake what you made is to find out the assembler directives, okay, which are also known as a pseudo instruction. Many of you have marked even the code as a pseudo instruction, but actually code is not a pseudo instruction. Okay, that is the most of the mistake what I found in your first sessional test. Okay, so whoever has their speaker or their mic on, please make it off. The Darsh Vagela. So today we'll see about the interfacing of the memory ICs with the 8086 microprocessor. Okay, as we know that the 8086 processor has, what is the maximum size of the main memory we can have? 2 raised to 20, that is equal to 1 megabyte. Okay, so around not 64 kilobyte, it is 1 megabyte. Since we have 20 address lines, so the maximum memory capacity would be up to 2 raised to 20, that is equal to 1 megabyte. Fine. So, but the available ICs, the ICs which are available with us, okay, or it is which is manufactured, all of them may not be of 1 megabyte capacity. Fine. So, say suppose if I'm having the IC of 1 kilobyte, fine. So in that case, I have to use number of such 1 kilobyte ICs to make it as a 1 megabyte memory capacity. Are you getting me? Okay. Similarly, the word size of the memory would also vary. Fine. So in case actually the word size of the memory here is 8 kilobyte, but the data bus is of 16 kilobyte. Sorry, no, not 6 kilobyte, it is 16 bits. Are you getting this? The word size of the main memory is of 8 bits, but the data bus is of 16 bits. So what, and as we know that that word is divided into two banks, or the memory is divided into two banks, that is even bank as well as odd bank. Followed? So I can connect one IC for the even bank, the other IC for the odd bank. So that I can have a word size of 16 bit, which can be connected to the data bus. Getting all of you? Okay. So in today's session, we'll be studying how to interface the memory ICs with the microprocessor. Follow? If you have any doubts, you can ask me. So this is what we have discussed. The processor has a 20-bit memory address, and the maximum allowed capacity of the main memory is 1 megabyte. Followed. Out of this, as I said, the ICs may not be of 1 megabyte. So out of this, only some of the address lines are directly connected to the address lines of the IC. Are you getting this? Because say suppose 1 kilobyte memory capacity is there. In that case, I can have address lines of how many bits? If the IC of 1 kilobyte memory capacity is there, then how many address lines would be required? Yes, 10 address lines. Fine. So that means we'll have 10 address lines, 10 pins would be allocated to provide the address for the memory. Followed. And similarly, we may have, say, suppose the word size is of 8 bits, then we may have eight data pins on that IC. Followed. Out of this, several address lines are, so if I'm using 1 kilobyte IC, then what happens is only 10 address lines would be used, whereas the remaining 10 address lines, because for the 8086 processor it is 20, so the remaining 10 address lines would not be used. Okay, and these 10 address lines, the remaining 10 address lines can be used for either the chip select, to select any IC, and based on that we can have the range of addresses. Okay, so the extra lines determines the range of address the memory interface occupies. How many, what would be the range of address would be allocated for this particular IC, for this 1 kilobyte of memory? What would be the address? Followed, because our address would range from 00000 till FFFFF. Fine. So that out of this range, what would be the allocated range for a particular IC, that we have to discuss, and that is determined by the remaining 10 address lines. Now, these extra lines can also be connected to the decoder circuit, and it determines the address lines and enables the memory for a range of addresses. Okay, so based upon the output of the decoder, we can find out what would be the range of addresses for a particular memory IC is provided. So we'll see with the examples here. Before going through the examples, we'll see what are the various address decoding techniques which are provided. The very first one is full decoding, and it is also known as a absolute decoding. So the remaining 10 address lines which are left, if I'm having 1 kilobyte IC, okay, so the all the rest of the 10 address lines are used for the decoding of that IC. Are you getting me? Okay, so the remaining 10 address lines, all those 10 address lines would be used for decoding of that IC, and hence it is known as a full decoding, or which is also known as a absolute decoding. The other type of decoding is a partial decoding, in which it may not use all the address lines, but some of the address lines can be used as a chip select for that particular IC. Okay, so that is known as a partial decoding. And block decoding, we may use some decoders, extra decoder circuits can be used to decode a particular inputs, whatever we are having. Okay, and this output of these decoders can be connected to the chip select line of the memory IC. So the very first example we'll see about the absolute decoding. Okay, as it is also known as a fully decoding. So you can see in this example, we are having two ROM ICs with the capacity of, say, suppose here it is using 1 to 13 address lines. So what would be the capacity now if it uses 13 address lines? 2 raised to 13, that is equivalent to 8K. Okay, 2 raised to 13 is 8K. So the capacity of this IC is 8K. So you can see that it is written here ROM 8K. Here also it is a ROM 8K. And as you know that these, as I said, we are supposed to connect two ICs, one for even bank, the other one for the odd bank. Okay, so you can see that this 8K IC is connected in parallel here. One represents the even bank, the other represents the odd bank. So can you tell me what represents the even bank, and how we can make out whether the data is fetched from or read from the even bank, or the data is read from the odd bank. How to select an even bank or odd bank? A0 as well as BHE bar signal. Okay, fine. So you can see here, uh, are you able to see this, the input of this OR gate, that is the A0 line? Okay, and here we are having this BHE bar signal. So this indicates the even bank and this indicates the odd bank. Followed? So lower order 8 bits are connected to this even bank, and the higher order 8 bits is connected to the odd bank. Now we are talking about the absolute decoding. In case of absolute decoding, you can see that since the memory capacity is of 8K, 13 address lines, that is A1 to A13, is connected to the address inputs of this IC, of this ROM IC, whereas the remaining address line A14 to A19, okay, so that forms a 20 address line. A0 is connected here, A1 to A13 are here, and A14 to A19 are here. Okay, that forms a 20 address lines, and the remaining address lines, that is A14 to A19, can be connected to this NAND gate. So here it should be NAND, not an AND gate. Now you can see that to get this address or to select these ICs, what should be these inputs? What are these what should be the inputs of this NAND gate from A14 to A19? All of them should be ones. Do you agree to this, all of you? All these address lines should be ones. Okay, so A14 to A19 are 1. So if it is 1, the output of this, here it is an AND gate, but it is a NAND gate. The output of this NAND gate should be 0. Okay, and if it is 0, since we are having the CS bar pin, that means when these ICs would be enabled only if the input to the chip select is made 0. Hope you all are getting this. Hello. Okay, so that means for to select this ICs, we are having a specific address. Are you getting this? If I change in any one of this bit from A14 to A19, this these ICs would not be selected. Do you agree to this? That means every memory location would have a unique address in this case. Followed? So this is about absolute decoding. Okay, the advantages of absolute decoding is that each memory location has only one address. There is no duplicate address for any memory location, and the memory can be placed at the continuous memory locations, okay, in the address space. Whereas, and the advantage of this is one more advantage, that if we want to expand in future, if I want to provide some other address, then directly what I can do, say suppose now I want to select, I want to have the address ranging from A19 should be 1, whereas A18 should be 0. In that case, I can connect one inverter in front of this A18, so that would have one some different address. Are you getting this? I want to select these ICs, or I want to select this memory only when A19 should be 1, A18 should be 0, whereas rest of all, A 17, 16, 15, 14, all of them should be 1. In that case, what I can do is, we can provide one inverter circuit, one NOT gate can be connected in front of, in between A18 as well as the input to this NAND gate. Okay, in that case, the address would be now different. Do you agree to this, all of you? Are you getting or not? Okay, so now the address would be different. Now the address would be 1011. So A19 should be 1, A18 should be 0, then A17 should be 1, and so on. Okay, now that would be my new address. Okay, so here that is what it says. It uses full decoding. Okay, and the future expansion can also be easily done in this case. So the disadvantages is that extra decoders are necessary, as well as delay will be produced by these extra decoders. So there, as the number of gates increases, the delay would also be increased. So that was about the absolute decoding. Next comes linear decoding, okay, or which is also known as a partial decoding. Here you can see that the similar 8K, in this example, they have taken this RAM IC. Okay, so the A0 is connected here, BHE bar is connected to this odd bank, and D0 to D7 is connected to the even bank, and D8 to D15 is connected to the odd bank. Fine. Now, here you can see that only one address line A19 is used to select both these ICs. Fine. So, the A19 pin, when it is 0, then in that case, these two ICs would be selected. Do you agree to this, all of you? Okay. Whereas the address lines which are connected to this IC is from A1 to A13, because it is at 8K. Now, A14 to A18 is not utilized. Now that A14 to A18 is don't care. You can use any of the addresses. Are you agree? Do you agree to this? That means if A19 is 0, irrespective of whatever be the bits of A14 to A18, it would select these two RAM ICs. Followed. So that means for a particular memory location in any of this RAM IC, it may have multiple addresses. Do you agree to this? Because A18 to A14 are different. Hello, is this thing clear? They can vary. Some say suppose if I take the example of A18, A18 is 0 or 1. In any of this situation, okay, it may select one of the memory location here provided A19 is 0. Getting all of you? That means multiple addresses are provided for a single memory location. This is what is nothing but the linear decoding. How about others? Understood?
Other ICs can have 18 as the serial number. So
Yes.
in that case, we have only A14 to A19. So the limitation
Limited circuit that is there. Here just say suppose one more such set is used, okay, and that is connected to A18 uh, address line. Okay, so in that means now when A18 is 0, that would be selected. Whereas if say suppose A19, either it is 0 or 1, it doesn't care. Followed. Now in that case, two memory location would have may have the same address. Okay, that would be the problem with this linear decoding. Are you getting this? Followed? So the advantage and the disadvantages of the linear decoding is the circuit is simplified, because you can see that directly the A19 pin is connected to the chip select line here. So the circuit is bit simpler. Multiple addresses are provided for the same location. That's what we have discussed. Okay, and complete memory space is not efficiently used. And address or interfacing ICs will with already existing circuit is difficult. So suppose I want to add some more IC, then again it would be very difficult to add, because it might be possible that two ICs, two memory locations may be having, I mean, they are pointing to, they are accessed by the same address, okay, but with different data. So which is not correct. Okay. The next is the block decoding. Okay. So here in this block decoding, we are using the decoder circuits. So you might have studied about the decoders, 3x8 decoder or 4x16 decoders, etc. So a single decoder can be used to as a chip select for multiple ICs or for a multiple set of ICs. So hence it is known as a block decoding. So in this system, the memory array is often consists of several block of memory chips. So in this example, what we have seen that only few memory chips we are using. Say suppose if I want to have the entire 1 megabyte of memory, but the available ICs of only 8 kilobyte, then we may require number of ICs. Okay. So we may have multiple ICs, we may require multiple ICs, and which could be connected in the form of block of array. Okay. And to select these ICs, we require the chip select signals. And this chip select signal can be generated by using this 3x8 decoders. Okay. Not only 3x8 decoders, uh, any n cross 2 raised to n decoder. Follow? To avoid separate decoder for each memory block, special decoder IC is used to generate chip select signal for each block. So we'll see how to do this. So arrange the available memories chip so as to obtain 16-bit data bus width. Okay, so if the word size of the memory is of only 8 bits, then we have to arrange it in two sets. Okay, and to make it as a 16-bit data word, the odd address memory bank would have uh, the upper 8 bit is having the it is represented by the odd bank, and the lower 8 bit is represented by the even bank, and D0 to D7 would be for the even bank, and D8 to D15 would be for the odd bank. Okay. Now connect the available memory address lines of memory chip with those of the 8086 microprocessor. Okay. And so the address lines, say suppose if it is 1K, then A0 to A9 of the address lines, not A0 to A9. A0 should be connected for selecting the bank. A1 to A10 should be connected to the address lines of that chip. Are you getting this? The address lines, the address bus what we are having, that A1 to A10 address lines should be connected to the address pins of the available IC. Okay. Apart from that, we have to connect the memory read and memory write inputs to the corresponding processor control signal. Okay. Uh, So here connection of the 16-bit data bus of the memory bank with that of the microprocessor is to be done. This is what we have discussed. And similarly, BHE bar as well as A0 signal should also be provided. So now, what are the steps? How to interface this 8086 static RAM as well as the ROM? We'll see. So calculate the number of memory devices which is required. Say suppose if I'm having 1K IC, okay, and if I want that the maximum capacity of the memory should be only of 64K. Okay, then what I can do? I can use such 64K by 1K. That would be the number of ICs which is required. Okay, so using this, calculate the number of memory devices. How many ICs are required, that we have to find it out. For that, number of memory device that the number of ICs is equal to required memory size. So if the required memory size in my example was 64K, and the available size of the memory, okay, the IC chip was of 1K. Okay, so 64K by 1K is equal to 64. So that means we require such 64 IC chips to get the memory capacity of 64 kilobyte. Okay, now once we have this, arrange these memory chips as the even bank as well as the odd bank. Are you getting this? So there should be 32 ICs which represents even bank. The remaining 32 ICs should represent the odd bank. Hope you all are getting this. Hello. Fine. So there are 64 ICs, 32 of them are for even bank, the other 32 would be for odd bank. Now determine the address lines of 8086 processor to be connected directly to the address pin of the memory devices. Okay, so A1 to A10 should now be connected in our example. A1 to A10 of the address pins, address line should be directly connected to the 10 address lines of the given IC. Followed? Then, since two memory banks are to be interfaced, so that two decoders are required for each bank. Two decoders would be required now for each of the bank. for memory for even bank as well as odd bank. The M slash IO bar and A0 pin are used to enable the even bank decoder. Are you getting this? So if I want to enable the even bank decoder, then I should have M slash IO bar. If it is memory, then it should be 1. If it is IO, then it should be 0. The IO devices can also be selected in the similar way. Okay. But now for the IO devices, the number of address lines would be only of 16 bits. Are you getting this? IO device, the IO ports can be accessed only using 16 bits, whereas the memory can be accessed by 20-bit address lines. Followed? So if we want to access the memory, then the M slash IO bar pin. So if you observe, if you go through the pin diagram, you have one of the pin is M slash IO bar. Okay. That M slash IO bar and the A0 pin. So both of them would enable the even bank decoder, whereas M slash IO bar and BHE bar pin. So these two are two different pins. Okay, BHE bar is for the to select the odd bank. So M slash IO bar and BHE bar pins are used to enable the odd bank of the memory. Okay. Now, if we want to interface with the EEPROM, follow? Uh, Whenever we reset the processor, the default address for when it resets is FFFF0. To select the number of ICs are there, to select the IC, we have to use the decoders. Understood? Okay. So there are certain examples of this. We'll see as we go further. EEPROM interfacing with 8086. So as I said, whenever we reset the processor, the default address uh, which the processor would point to when it resets, it is FFFF0. Okay. And that that address should be the, or it should be the EEPROM address. Why is it so? Why it should be the EEPROM address? Any one of you? So whenever, even in our system, when we boot, okay, we have the RAM as well as ROM in all of the systems we have. When we boot directly, it would check all the interfaces, it will check the working of keyboard, and if something goes wrong, it shows some message. Do you agree to this? Okay. So from where you get this message? Okay. Now that program should be where? If it is in RAM, then what happens when we shut down our systems? The content of the RAM would be lost. Are you getting this? Okay. Whereas if it is already stored into the ROM, then at a particular address, so whenever you start your system, directly it would point the CS as well as IP would be pointing to that particular address, where it would execute the program to check the devices or the interfaces which are connected to your system. All of you are agreeing to this? Okay. And that program should be into the ROM. Then only it would be permanent, isn't it? Or else it would be lost. So here also the microprocessor, when it is resetted, some program would be written, and the CS as well as IP would be pointing to that particular program. The CS value would be FFFF, and the IP value would be 0000. Okay. So the CS and IP would be pointing to that address where certain program for uh, initializing or some code would be written into this ROM, and that would be executed. Hope everyone is clear. So or usually whenever you are providing the addresses to the RAM IC or ROM IC, the FFF0 should always be for the ROM. Do you agree to this, all of you? Why is it for the ROM? Hello, is this thing clear, everyone? Okay, so whenever the 8086 CPU is reset, its value is set to FFFF and IP value is 0000, which corresponds to the physical address FFFF0, which is always a part of ROM. This means that FFFF0 to FFFFH should always be included in the ROM. It should be the ROM IC. Followed? So now we'll see an example of interfacing a RAM module to this, how to interface a RAM IC, which is of whose capacity what we want is 64 kilobyte. How should be how it should be interfaced with the 8086 processor, and the address what we want to provide to this memory, to this IC, is C0000H. This is our this is the address what we want to provide. Okay, so now we'll see how to interface, what pin should be connected to the IC, which pin should be connected, how the address should be decoded, how the address should be provided as a chip select line. So that we'll discuss using this example. So now, since we want a capacity of 64 kilobyte, and as we know that it should be divided into two banks. One, the 32 kilobyte should be meant for the even bank. The remaining 32 kilobyte should be meant for the odd bank. Okay. So this 64 kilobyte should be split into two banks. Okay. One of them is a even bank. The other one is for the odd bank. So the the least significant addresses is if it is 32 kilobyte memory, the number of address pins which is required would be 15. Do you agree to this, all of you? Okay, so A1 to A15 should be connected to the address lines of both these ICs. The A0 pin should be connected to the even bank for selecting the even bank, whereas BHE bar signal should be connected to the odd bank. Do you agree to this, all of you? Hello. Okay. Hello, is this thing clear? Among these 20 address lines, since I want to address 32 kilobyte, because each IC is of 32 kilobyte, A1 to A15 can be connected to the address lines of that IC, whereas the remaining A16 to A19 can be used for selecting the IC, or you can be connected to the chip select line. Hope everyone is clear. Students from the online mode. Okay. So now the address range what we required is C0000 onwards. Okay. So you can see that this is A0 to A19. C is nothing but 1100. That is 12. C is nothing but 12. This is 1100. And the other bits are all zeros. Fine. And A1 to A15 is there. So here all these should, the last address should be all these ones. Do you agree to this? 64 kilobyte if it is there, then it requires 16 bits. So A0 to A15 we are using to address the 64 kilobyte of memory. Whereas the remaining A16 to A19 can be used as a chip select line. Hello, is this thing clear, everyone? Shall I repeat it once again? The required address is C. Clear, or should I repeat? Okay. Here it is given that the required IC, the is of 60, the required memory range is 64 kilobyte. And since I want a range of 64 kilobyte, I have to divide the 64 kilobyte into two banks, even bank as well as odd bank. Okay, which is of 32 kilobyte each. To address this 32 kilobyte, we require 15 address lines. That is A1 to A15, whereas A0 line is used for selecting the bank, Okay, as you know, and it is given that we want the address, they have given that the memory whatever we are connecting, the address range address should be from starting from C0000 onwards. So that we are showing here, this is C1100 and rest of all are zeros. Okay, now the address A1 to A15 would range from 0 till 1. Do you agree to this? 0, the starting address would be all zeros, the ending address would be all ones. And A0, to select the odd even bank, it should be 0, and to select the odd bank, it should be 1. So total range would be, total address range would be C0000 till CFFFF. Is this thing clear? Okay. Yes. So what we can do is, the control bus of the is interface to the SRAM as follows. We have to decode the M/IO bar, read bar as well as write bar signal. So how can you decode it? Either we can use a 3x8 decoder. We can use a 3x8 decoder. Is this thing is visible, the whiteboard? Okay. So in our 8086 processor, we have M/IO bar, read bar, write bar signal. Okay. Such pins are already available. So I have to use this to get this memory read bar, memory write bar, then IO read bar. Are you getting this? We are having M/IO bar, read bar, write bar. 3 different pins are there of 8086. So using these 3 pins, I have to get these lines: memory read bar, memory write bar, IO read bar as well as IO write bar. Do you agree to this, all of you? So for this, I can use a decoder. A 3x8 8 decoder can be used. To this, I can have 3 pins inputs: M/IO bar, read bar as well as write bar. So if it is 000, then it should be memory read bar. If it is 001, then it can be memory write bar, and so on. Like this we can, or if it is, say, suppose if it is 0 here, and read bar is 0 and write bar is 1, because read and write cannot be done at the same time. So what would be the output here at pin number 0? If I want to select memory, it should be 1. If it is IO, it should be 0. So it would be IO. Say suppose this pin is read bar. So and that is 0. Read bar, it is bar. That means it is IO read operation, IO read bar operation. Similarly, if it is 001, 010, in that case it would be IO write bar, and so on. Whereas if this pin is 1, then accordingly it would be memory read bar as well as memory write bar. Hope everyone is clear with this. Hello, is this thing clear? This is how you can get these control signals: memory read bar, memory write bar, IO read bar as well as IO write bar. Decode the M/IO bar, read bar and write bar signal to generate 4 signals: memory read bar, memory write bar, IO read bar as well as IO write bar. Now connect the memory read bar to the output enable bar of the RAM IC, and memory write bar to write enable bar of the RAM IC as well as the ROM IC. Okay. Whereas the data bus should be connected, D0 to D7 should be connected to the even bank, as well as D8 to D15 should be connected to the odd bank. So you can see that this is how it can be interfaced. So You are having two ICs, 32K by 8, 32 kilobyte ICs. Are you getting this? We require the capacity of the memory is of 64 kilobyte. It is divided into two banks, uh, even bank as well as odd bank, each of 32 kilobyte. So this is 32 kilobyte and this is 32 kilobyte. Followed? And since we are having 32 kilobyte, that means 15 address lines would be required. You can see that A1 to A15 is connected to both of them. Hello, is this thing clear, everyone? So 15 address lines are connected to both these ICs. The address lines would be common. Then you can see that memory read bar, memory write bar is connected here, which we get it through the decoder, which is now just now we have discussed. Then a decoder IC is required so that A16 to A19. So that can be the input to this decoder IC. Okay. And as we know that the output of the decoder, only one of the output of the decoder would be uh, high. In case here, if I am considering that we are having active high output of the decoder, whereas if it is an active low input, so here it is, since it is shown as a bubble, that means only one of the output is zero, whereas rest of all would be ones. Are you getting this? That means the decoder is an active low output. Okay. So here you can see that when this decoder output is zero, okay, so you can use this A16 to A19 line, which is connected to this input to the decoder, and only one of the output of this decoder would be zero, whereas the other outputs would be one. And you can see that to select this even bank, I am having A0 pin, whereas to select the odd bank, we are having this BHE bar pin. Now this is zero, and if this is zero, so you can see that this is an inverted input which is given. So that means here it would be both of them are ones. Okay. When these two are ones, the output of this would be zero. And if this is zero, you can see that this chip select line is there. Okay. That means it is selecting this even bank. Similarly, if BHE bar is also zero, then it also selects this odd bank. Okay. This is how this BHE bar and A0 pins are connected to this even bank as well as odd bank, whereas the address lines A1 to A15 are connected to these two ICs. Whereas the data bus, among this data bus, D0 to D1 D7 is connected to this even bank, and D8 to D15 is connected to this odd bank. Followed, everyone? So the decoder, you all are aware about the 74LS138. Okay, you might have studied in your DDC. You know the working of decoder. ABC are the select inputs. If this is 000, then output should be 1, but here it shows the active low outputs. That means the one which is used here, the input what we are having, that particular output would be 0, whereas rest of all would be 1. Okay, so you can see that when ABC is 000, and if this the output 0 would be 0, whereas rest of all are ones. Similarly, when it is 001, the output 1 would be 0, whereas rest of all are 1. And this G2A, G2B as well as G1, it shows the chip select line. Are you getting this? This is particular for this particular 74LS138. It is a 3x8 decoder. To select this decoder, what we want is, or to enable this decoder, this pin should be 0, G2A should be 0, G2B should be 0, as well as G1 should be 1. Okay, so you can see that this is G2A is 0, G2B is 0, G1 is 1. Only in that case, it would work as if it is a decoder, or else it would not work. Getting all of you? Okay. So we'll see one more example. Interface two 4K by 8 EPROMs and two 4K by 8 RAM chips. Okay. So now we want a memory of two 4K by 8. That means 8K by 8 EPROM should be there, as well as 8K by 8 RAM should be there. That is our total capacity of the memory what we require. So we have to show all the connections, how we make, what are the address lines which are required for each of this IC, and how these ICs would be selected. That we'll discuss. So as we know that uh, if no such address range is given for the ROM, then by default the IC, the address which we have to provide is FFFF0 till FFFF. That we have discussed why it is so. If it is not, if they haven't, in the earlier example, it was given that we have to use the RAM IC and the address would start from C0000 onwards. But in this example, no address is given, and they have provided that we should have this EPROM. For that case, we have to use the address range from FFFF0 till FFFFF. By default, it should be for the ROM. Okay, and why it is so, that we have already discussed. Okay, so since after reset the IP and CS are initiated to form the address FFFF0, and this address must lie in the EPROM. Okay, so that address should be specifically for the EPROM. The address of RAM may be selected anywhere. The RAM address, it is not compulsory that it can it should be it can be selected anywhere, but in this example what we are considering that it should be continuous. Okay, once the ROM addresses finishes, then from there onwards we'll start with the RAM addresses. Are you getting this? In this example we are considering that the RAM address should be followed following this ROM address. Okay, anywhere in this 1 mega, the RAM address can be selected anywhere, but in this example it should be we are considering that it should be continuous. Okay, so it is given that 2 4K ROM. Okay, so one 4K ROM should be for the even address, the other 4K ROM should be for the odd address. Okay, so to have this 4K, the number of address lines would be how much? 12 bits. Okay, 12 bits for the even address, 12 bits for the odd address, and one more bit to select the bank. So A0 to A0 to A12 would be there, but A0 is used for chip select or for selecting the bank. Then now we are considering A1 to A12. Hope you all are getting this by A1 to A12. Okay, because it is a 4K ROM. Not clear? See, each IC is of 4K by 8. So the address lines would be 12 bits. And to select the bank, I require one more bit. And as we know that A0 is specifically used for to select the bank. You agree to this, all of you? So A0 is used to select the bank, whereas A1 to A12, 12 address lines are used to select the memory of that particular IC, the memory address or memory location of that particular IC. Hope this is clear, everyone. Okay, so total 8K of EPROM or RAM is needed. Okay, and it may require 13 address lines. But among this 13 address lines, A0 is used for selecting the bank, whereas A1 to A12 is used for the IC. Followed? Whereas remaining address lines, now A13 to A19, these many address lines are used. That is used for decoding this IC chip, to decoding the IC, and that is can be connected to the chip select line. Followed? So as we know that the starting address of the ROM, it should start from FFFF0 till FFFFF. So we know the ending address. So this is your F, A19 to all these ones represents the FFFFF. Okay. Now, since it is a 13 A0 till A12, so what would be the starting address of that particular ROM IC, ROM chip? You can see that here A0 to A12 is my address range. Okay, So the starting address would be A0 to A12 would be all zeros. The ending address from A0 to A12 would be all ones. Do you agree to this, all of you? Hello. A0 to A12 because it is a 8K by 8 ROM. Okay. So 13 lines would be there. So which would range from A0 to A12. So all of them are ones here. And the starting address for that would be all zeros. Hope everyone is clear. Hello. How 13 lines? Okay. So what we are having for 4, it is given 4K by 8. 4K by 8 means what? It would be 8K by 8. If it is 8K by 8, 13 address lines would be required. Hello, is this thing clear? But among these 13 address lines, A0 to A12, A0 is used for selecting the bank. The remaining 12 lines are used as for the address. It can be connected to the address input of each of them. 12 lines for each of this IC. But to select the bank, we require one more pin or one more address line, that is A0. That means 13 address line from A0 to A12. We are starting from A0, isn't it? So it would be A0 to A12. This is what I am showing. This A0 is used to select the bank, whereas A1 to A12 can be connected to the